All right, good morning, guys. So I am going to go through packet 5, 6, and 7 today, but there will be a separate video for each. So on packet 5, I did it in a hurry the other day, and I got a little mixed up. So be sure to pay close attention on numbers. Let's see. 5, 6, 7. Maybe it's just 5, 6, and 7. Anyways, what I've done is I've swapped the X and Y intercepts and just wrote them in the wrong spot. So just pay attention. You'll notice it when you've worked it anyways. All right. So first, we need to be able to recognize these graphs. Square root, is an eyebrow. Okay. A cube root has the little 3 right here. Okay. If you just graph the cube root of x, you will get something that looks like this. Okay. Exponential, y equals b to the x, that's kind of like a Nike sign. Okay. A log, if you just graph a simple log, it looks something like this. The difference in that and the square root is that the log goes across that axis, whereas the square root stops. And a reciprocal, we haven't really done much of that yet, but it's 1 over x, and it's an L this way and this way. Okay, so just be able to recognize a reciprocal, but it's just the opposite. That's all that means. All right, so on number 1, it asks us to identify the function family and describe the transformation. All right, the transformation rules are still the same. Okay, they will never change. On number 1, using what we've just written above, which function family does that look like? Okay. It looks like a reciprocal because it has 1 over x something. Okay, so it's a reciprocal. Okay, this bottom part is used as the horizontal. Okay, horizontal is like in the parentheses or in some brackets or in the absolute value. In this case, it's in the bottom. Okay, same thing. All you're doing is thinking, well, x minus 4. When I see that and it's a horizontal asymptote, I know that means it goes right 4. Okay, horizontal on the bottom. Okay, that 9 on the outside, that's our vertical, and obviously you know that it goes up 9. Okay, if you wanted to, you could graph that and it would show you all that as well. All right, number 2, since we have this little cube, it's a cube root. Since we have that negative 2 out front, it does 2 things. It reflects over the x, and it also stretches the x minus 7 under the square root. It's the horizontal component. By looking at it, you know it means it goes left 7. And then that positive 1 on the outside means that we go up 1. Okay? All right. Let's see. All right, so all of these graphing, remember last week I told you we would not be doing the end behavior part, so you can go ahead and mark out that end behavior. All right, so what we're going to do now is we're going to graph these in Desmos. So you can do this in your calculator as well. Go to your y equals. Does the same thing. I just don't have the calculator on here. Oops. All right, so we are typing in let's start y equals. Y equals 3 where's this? Oh, there it is. The square root of x, and then look, that plus 1 is on the outside. All right, so there's our graph. You'll notice that it starts right here at 1. Okay, so if we go back to our paper, what I want you to do is sketch your graph and just show that it is starting at 1. So since it's starting at 1, our y-intercept is 0, 1. Do we have an x-intercept? Does it cross? No, so we're going to put NA. All right. Is it increasing? Yeah, it's increasing. Where is it increasing? Well, it is increasing from 1 to infinity. Does it decrease? No. Remember, domain. X, range is Y. Looking at the domain, okay, where does it start on the X? Well, look at your point. 0, 1. Okay, so it starts at 0, but is everything greater than 0 or is everything less than? It's greater than, okay? So our domain would be x is greater than or equal to 0. That means everything above it is greater than that 0, okay? Now our range is our y, okay? What is your y point? Well, your y point's 1. So it's above 1, so everything is greater than or equal to 1. All right, on the next one, we're going to graph y equals negative square root of x plus 5 and then minus 2 on the outside. We have to zoom out to find our graph. All right, here's our graph. All right, it shows us, let me zoom in just a little bit. It shows us that our graph starts at -5, -2. And we have a y-intercept at -4.236. So I'm going to sketch this graph. 1, 2, 3, 4, 5, 1. Oh, that's kind of bad. All right, so it's going to look something like that we don't have any zeros. I just said that our x, or our y, sorry, is negative 4.24 if we round. Does that increase at all? No. Does it decrease? Yes. We're going to use our x point. So we've got negative 5 to infinity because it just keeps going and going. Let's go back to the domain. Domain is x. Range is y. All right, it starts at negative 5. All of the y values are to the right of negative 5. All of this right here. It's all to the right. So all of those values are greater than or equal to negative 5. Okay? If we're looking at the y values, it starts at negative 2, and everything from here down is below. So y is less than or equal to negative 2. All right, number 5, we are going to graph y equals let's see if we can do a all right, on this one, if you graph it, let's look at the transformations. Let's pretend we don't have a calculator here, okay? We know it is we know it is a cube root. All right, we know by x minus 1 that it is going to go to the right 1, and because of the 4, it's going to go up 4. All right, so we want to go from 0 over 1 up 1, 2, 3, 4. Okay, since the 4 is right here, this has got to be our y-intercept. So our graph might look a little something like this, okay? We use the point 1, 4 from our transformation to plot. All right. So by looking at our graph that we've drawn, domain and range, easiest thing is the all real numbers, or also known as negative infinity to positive infinity. Okay. Now, here's where I have messed up. If you graph these, and you won't have one this big of a graph, but when you graph this, you will not be able to see this x-intercept. So, for right now, I just because, negative 63, 0. So what you would have to do is zoom out of your graph, like tremendously. Okay. However, we can see that y-intercept, and we know it is 0, 3. And you can do that on your calculator or Desmos. You can zoom out and see it. Now, what I've uploaded for the answer key is the opposite. I have written the y-intercept on the x and the x-intercept on the y, okay? So, just be sure you flip those, okay? I've also written this fancy R. All that means is all real numbers, okay? Nothing fancy, just all real numbers. So on this graph, is it increasing? Yes. Negative infinity to positive infinity. Is it decreasing? Nope. Not decreasing. Okay. Now, same thing on number 6. What I have done on the answer key, if you are looking at it, is I have swapped them. I've written the y-intercept on the x and the x-intercept on the y. So just be mindful of that and change it. Okay? Same thing on number 7. I've swapped them. Be sure to change it. So 6, 7, 8, 9, 10, 11, and 12. Well, let's just do up to 10, and let me do 11 with you. Yeah, let me do 11 with you. All right, so 6, 7, 8, 9, and 10 are just graphing, okay? Nothing new. If you look on number, let's see. Number 9, you'll see the word asymptote. All that means is it comes really close to touching a line. Okay? Comes really close, but it does not do it. And if you want a hint, it's your horizontal component. So our horizontal component is x plus 6. Well, we know when that says x plus 6, that means that it is left 6, which is a negative 6. Okay? So over here, this one would be x minus 1. Well, we know that it goes right 1. So x equals 1. Okay? All right. Excuse me. Let's do number 11, because that's a new reciprocal. So we got y equals, we got a fraction bar, negative 1 on the top, and x minus 2 on the bottom, and plus 5 on the outside. Whoop. Plus 5. There we go. All right. Here's our graph. We got a reciprocal. So, I want you to sketch that on your graph. Looking at it, the domain. This is a little bit tricky. The domain is by x. The range is my y. All right, looking at your domain. Well, before that, looking at your transformation rules. What is the horizontal component, the x component right here? If we set that equal to 0, that's going to be 2, comma, and then this is just easy. That's just going to be 5. All right, so your domain. If you look right here, here is x equals 2. What do you notice? It comes very close to touching it. Same thing with this or y equals 5. It comes very close to touching it, but it does not quite touch it. Okay? So your domain is when x is everything but 2, because it never actually touches that 2. Your range is when y is everything but 5, because it comes really close to touching that 5, but it never actually touches it. Okay? If you click on your graph, you'll see your x and y intercept. Have I done the same thing here? Yep, I've done the same thing on this one. Number 11, I've got them swapped. So your y-intercept is about 5.5, and your x-intercept is about 2.2 maybe, roughly. Okay. Now, increasing. First of all, is it increasing? Yeah, it's increasing from here to here, and then it's increasing from here to here. But think about the vertical asymptote. It does not touch. It does not touch this 2. So it is increasing when everything but 2. And we haven't really touched on this because we haven't got to it yet. So fingers crossed we won't have a lot of problems on it. All right. Let's see. Vertical and horizontal asymptote. You know that. Vertical is my X point, and horizontal is my Y. So vertical is 2, horizontal is 5. Okay, and that comes from this point right here. All right, try 12. It's done the exact same way. All right, almost done with this one. Very, very easy. Which function does this belong to? Well, we just wrote it in the first problem. A cube root. This one we didn't write this, but you know that a v is an absolute value. All right. Number 5, we wrote that one down. You know that is a reciprocal. You may also see it as rational, but probably just reciprocal. Okay. All right, right here on this one, you can do it 2 ways. If you have a calculator, you can graph it. If you don't have a calculator, you can factor it and find your x's. So let's factor. The first 3 terms have an x. So we've got an x squared plus a 2x minus a 9, and then minus that 18. We know this 18 has got to be our y-intercept. All right, let's do this. Let's see what happens here. We multiply to negative 9. Let's see. I don't don't think we can do the big X this way. Adds to 2 and multiplies to 9. Well, 1 and 9, that wouldn't work. And 3 and 3, that wouldn't work. So, we cannot do that. My suggestion here is to go to your lovely y equals in your calculator and type in x cubed plus 2x squared minus 9x minus 18. Bam, look, it tells you everything right here. Here's an x, here's an x, here's an x, and here's a y. Okay? Now, number 17, we can do without graphing. Here's why. We've got a log base and it wants to know the vertical asymptote. Guess what you do with this little component right here? X plus 3 equals 0, minus 3 minus 3, x equals negative 3. Okay? All right. On number 18, identify an interval that the function below is decreasing throughout. Y equals parentheses 2 minus x squared minus 7. Well, it is decreasing from here all the way to right here. So that looks like negative infinity to positive 2. Okay. All right, give the range. Number 17, y equals 1 over 3, x minus 1 minus 5. All right, our range starts. Let's do a little zoom in and see what it does. There we go. Our range starts at what looks like 5, and it goes to starts right here at 5. Everybody see that? And it goes up. So the range will be y is greater than negative 5. Now, why did I not put y is greater than or equal to negative 5? Because it does not actually touch that negative 5. Okay? All right. Number 20. Give the end behavior. All right, look. 2 things. Odd power and positive leading coefficient means 2 things. Left side points down, right side points up. So it looks something like this. Okay. All right. I think that's it for topic 5 or packet 5. So do the quiz, check your answers, be mindful of where I've swapped some things. Sorry. I'll post that too though in just a minute. All right. See ya.